Hello everyone, this is Mr. Appel, and today we're going to continue to look at probability. So let's get started. We're going to kind of step things up a little bit of a notch. The first day we looked at just kind of very basic probability stuff you've probably seen before. Now we're going to expand on that a little. So the first situation we're going to look at is or situations. So a probability that something happens or something else happens. I know that's kind of vague, but we'll look at a couple examples and make that clearer. So what happens in an or situation, the simplest way to calculate that is to calculate the probability that the first event happens, to calculate the probability that the second event happens, but then we also have to account the probability that both things happen. So the example we're going to look at in just a second is if you're drawing cards from a deck and you're interested in the probability, well, I'll give you a preview of it, of getting a card that is either a jack or a red card. So either a jack or a red card. So event A would be getting a jack. Event B would be getting a red card. But if you count all of those up, all the jacks and all the red cards, in fact, let's just jump to this one. If you counted up all the jacks, so there are 4 jacks in a deck, and if you count up all the red cards, there are 26 red cards. So you might say there's 4 plus 26, there's 30 ways. The problem is 2 of those jacks are also red cards because 2 of the jacks are red. So if you count all of those, if you were to just add those together, you count the red jacks in both categories, you count them twice. So what we do is we subtract out the duplicates. So we would subtract out the 2 cards that are both red and a jack. And so you would combine that together and you would get 28 possibilities out of the 52 total. So I'm going to go back and look at what that looks like in terms of like a formula. So the probability of A or B, which is just the probability of the union of those 2 events. So in my example, getting a jack, getting a red card. The union, remember, is ones that are either A or B. So that's why we're talking about or here. The formula is the probability of A plus the probability of B minus the probability that the thing is both. So this is where you're subtracting out the duplicates. So this is the formula, but I think it logically just kind of makes sense. I want to be clear here that we are talking about mutually exclusive events. So 2 events that don't occur simultaneously, they don't impact on each other. So you draw a card, you get a jack, you get a red, it's just drawing a card. There's, well, we'll get into more specifics of that. It was a poor explanation, but I'll explain it better as we go forward. But mutually exclusive events are events that don't conflict with each other. So let's go back and look at another example here. If I wanted the probability of getting a card that is either red or black, now you may be saying, well, all the cards are either red or black, so the probability is certain. It would be 1, or 52 out of 52, and you would be right. But if we stick with the formula that we just saw, it would be the probability of getting a red plus the probability of getting black minus the probability of a card that is both red and black. Well, what's the probability of a red card? That's 26 out of the 52 are red, plus the probability of getting a black card, which is 26 out of the 52, minus the cards that are both black and red. Well, none of them are black and red. So the formula still holds true, because 26 plus 26, that's 52 out of 52. So the formula works even though you probably didn't need it in that example. That formula will come in handy a little later. Okay. And probabilities. And probabilities are essentially the counting principle. It's going to be kind of the same thing, but we can multiply probabilities. So probability of A and B, or the intersection of A and B, which are things that are both A and B, you can simply multiply the probabilities together. And again, these are mutually exclusive events. So for example, if you're taking a multiple choice test with 2 questions, 5 choices each, and we wanted to know the total number of possible outcomes if you were guessing randomly, right? So you would have said, all right, there's 2 possibilities, the first question, the second question. How many choices for the first? There's 5. How many for the second? There's 5. So you would have 25 possibilities. Well, now you're going to do that same idea, only with probabilities. So the first question, what's the probability of randomly guessing right? Well, we're assuming one correct answer out of 5. Multiply that by the probability of getting the second question right randomly, one correct answer out of 5, and you multiply those probabilities, and there's 1 out of 25 chance of getting both questions right if you were guessing randomly. And again, those two are mutually exclusive. What you choose for the first question has no impact on the second, and vice versa. They're independent of each other. Another example, if the first question is 5 choices, second question is 2 choices, use the same principle. First one, the probability of getting that right randomly is 1/5. The second one, the probability is 1 out of 2. And so the probability of getting them both right, if you were randomly guessing, is 1/10. So make sure you know what you're doing and don't guess randomly, because that's not pretty good odds. Okay. Kind of touched on this already, but the difference between independent and dependent events. Independent events where one event does not affect the probability of another. So the example we just gave is a perfect example of independent events. If you're randomly answering questions on a test, your answer for the first one has no bearing on whether you get the second one right, and vice versa. Dependent events are ones where whatever happens in the first one affects the probability of the other. The simplest example of that is if we're choosing, let's say, marbles from a bag or something like that, or even letters in the alphabet for a license plate. We did with replacement, without replacement. With replacement, there's no impact. So if you pick something out of a bag and then you put it back and you draw again, everything is just the same probability the second draw as it was the first draw. But if you're doing something without replacement, what happens on the first draw does affect what happens on the second draw, because now on the second draw, whatever you picked on the first one isn't available to be picked again. So again, that was very wordy. Let's take a look at an example that will hopefully clear it up. So the simplest example to use, I think, is a bag of marbles. So we've got 5 reds, 4 blues, and 6 yellows. If you're going to reach in and randomly grab a first marble and then a second marble, I want to know the probability of the first one being red and the second one being blue with replacement. So with replacement, so the first marble being red, there are how many there? 6 and 4 is 10, so there's 15 possible marbles on the first draw, and how many of them are red? 5. So the first draw, there's a 5 out of 15 chance of getting that event happening, the marble being red.
If there is a Nina in the building that ordered pizza, please come to the main office.
Sorry guys, I didn't order pizza. That's pretty funny. And the second marble, never a dull moment in pre-calc videos. Okay, the second marble being blue, so there are 4 blue marbles, but there are still 15 to choose from because the first one you picked up, you put back. Okay, so that's 20 out of 15 times 15 is 225, and we could reduce that. What is that? Well, if we reduce this one to a third, that's easier, so that's going to be 4 out of 45. Sometimes we'll put that in the calculator and go decimal. We'll get more into when it's appropriate to put decimals in, but if we do 4 out of 45, we get about 8.9%. 8.9%. But I'll usually specify how to write your answer, but generally speaking, best thing to do is leave it as a fraction in simplest form. Okay, now what's the probability? Same situation, but now without replacement. So whatever you draw on the first one, it doesn't get put back, so you can't pick it again. So the first draw, marble being red, there are still 5 red marbles out of the 15 remaining. Now for the second draw. If you picked, we're trying to see the probability of getting a red then a blue. So if you got a red on the first draw, there's now only 14 marbles to choose from on the second pick because you didn't put that one back. How many of those 14 are blue? Well, still 4 of them. And so now the probability is 20 out of whatever that is. Where'd my calculator go? 15 times 14. Whoopsie, sorry. Try that again. 15 times 14, which is 210. And you see that the probability changes. It's a little more likely to happen. If you wanted to calculate that, it's 20 divided by 210, which is about 9.5%. So it's about 9.5%, which would be one way to write your answer. But if I'm just reducing that, that's 10 out of 105. 5 goes into 10 twice. 5 goes into 105 21 times. So 2 out of 21. And that's it. That is probability day 2. Good luck. Thanks.